11.5, we're going to be talking about the normal distribution. Our previous lesson was talking about the binomial distribution, which had a discrete variable, right? This is a continuous variable distribution. So it's going to be a little bit different, slightly different. All right, we'll ignore this for a sec. Let's talk about properties of a normal distribution. All right, first off, typically when you guys are asking for a curve on a test, have you guys ever asked a teacher for a curve on a test? Nod your head, all of you have asked me before, okay? You actually don't want a curve. Traditionally, when, I think in universities people did this, a curve meant you would force all the grades to fit into this shape, right? And then this portion of the class, right, it's about 68%, automatically gets C's. Right? So the middle 68% gets C's. This section would get like B's, and then anything above would get A's. This would be D's, and this would be F. All right. So no matter how easy or how hard the test would be, right, the middle 68% would get C's no matter what. So I doubt that's really what you guys want. Okay. And a very low percent would get A's, but a very low percent would get F's too. All right. But that's what it meant to curve a test. You're trying to beat out other people. Okay. So, properties of this curve, don't worry, I'm not going to curve your tests. All right. Properties of a normal distribution. It's bell-shaped, as you can see. The mean, median, and mode are all equal and located at this center, all right, line. It's unimodal, meaning it has one bump. It's not like multimodal. It's symmetric about the mean. This is a pretty important one. All right, that's going to be useful. It's continuous, all right, so it's smooth. Never touches the x-axis, so this just keeps on going forever, but gets closer and closer and closer and closer to the x-axis, so it's like very, very close. And the total area under the curve is 100% or 1, right? So this is a probability distribution, so the area under the entire curve is going to be 100% or 1. All right, so one of the things I want you guys to note is this empirical rule when it comes to this normal distribution. And the empirical rule tells you what percent of the data is within these lines, all right? So the first one is the 68%, all right? So 68% of values are within 1 standard deviation from the mean. So that means if I were to step out 1 standard deviation to the left, 1 standard deviation to the right, in a normal distribution, this would be 68% of the entire curve. Alright, so that would be 68% of the entire curve. Alright, so if this was again like grades, 68% would automatically get C. The middle 68% gets, this is a real curve for grade. Alright. 95% would be within 2 standard deviations of the mean, right? 95% is within 2 standard deviations of the mean. So if I were to go out from here, it's too far, to here, that would capture 95% of the data. So that's this shaded region under the curve. Right, so that's about 95%. Of the entire area. So that would mean, again, if this was grades, 95% of you would get anything from a B to a D. Alright, B to a D. Okay. And then lastly, 99.7 is within 3 standard deviations of the mean. 3 standard deviations from the mean. So that means if I step out here, all the way to the other side, this would capture pretty much all of it, right? 99.7%. So that's pretty much the entire curve. Would be within 3 standard deviations of the mean. All right, so that is the empirical rule. So how do we use it? Well, questions kind of like numbers 1, 2, and 3. So for example, number 1, a normal distribution. All right, so normal distribution tells me I can use this. I can use the empirical rule. Has a mean of 287, standard deviation of 65. What range of values represents the middle 68% of the data? All right, well, I know the middle 68% is just 1 standard deviation down, 1 standard deviation up. So I'm just going to go 287, got my calculator. 287 minus 65, so that's 222, and 287 plus 65, 352. All right, so visually, I'm imagining doing this. 1 standard deviation down, 1 standard deviation up. And I know that that is going to be my 68%. All right. Questions on that so far? Okay. All right, part 2. What percent of data will be more than 417? All right, so if I add another 65, I see that 417 is 2 standard deviations above the mean. All right, so I'm trying to figure out, well, what percent is more than the 417? So I'm trying to find this area up here. Yeah. All right. Well, now, I know if I were to go down 2 standard deviations, this would be 157. I know from here to here is 95%, right? So I take 2 standard deviations away from the mean. So I know that 5% is left on this outside, right? 100 minus 95. So combined, these two should add up to 95%. So how do I just get this top part? Divide by 2. Yeah, because we know it is symmetrical. There it is. All right. So it's symmetric. So I know I could just divide it by 2. These are the same, right? This and this will be the same. So 5% divided by 2 will get me 2.5%. 2.5% of the data would be more than 417. All right, number 3. What range of values represents the low 0.15% of the data? All right, well, let's see what that middle percent would need to be for me to have just the low 0.15. So probably going to be 3 standard deviations. All right, so if I subtract 65, that's 92. All right, if I take 100 minus the 99.7%, and then if I were to divide that by 2, I should get, 0.15%. All right, so I'm looking for, that's this piece right here. This is the bottom, 0.015%. It's 3 standard deviations away. All right, but just the lower half, which is why we're dividing by 2. So anything less than 92 would represent the low half, or the low 0.15% of the data. All right, so that's how you use the empirical rule, right, to find something like that. Okay, questions about the empirical rule? Okay, all right, so use the fact that it's symmetrical, right? We used a lot of this, we used a lot of this, okay? So use those properties to help you with that, as well as the empirical rule. All right, let's get back to that formula that we ignored from before. So numbers 4 through 7 uses this formula right here. Now this formula is known as the z-score formula. The z-score formula. standard deviations you are, or your value is, away from the mean. And your value is just whatever your x is. Okay? So how many standard deviations away your value is away from the mean? All right. So for example, number 4, it says find the missing variable and indicate the position of x in the distribution. All right, so I'm just going to use my formula. I want to find out what z is. So plugging in, I get 81 minus 67 divided by 11.3. And that gives me 1.239. All right, so I get z is equal to 1.239. So what does that tell me about where my mean is? Well, that means x equals to 81 is 1.239 standard deviations above the mean. 1.239 standard deviations above the mean. How do I know it's above? It's positive. Right? If this number was less than 67, that would come out negative. But because 81 is higher than 67, we know it's above the mean. And z comes out to be positive. All right, let me jump to 6. I want to find x. If I know z is 1.34, mean is 81.1, standard deviation is 6.6. All right, so multiply both sides by 6.6 and add the 81.1. Okay, so I get x is equal to 72.256. All right, and what does that tell me? Well, x being 72.256 is, now notice here, I'm not going to put negative 1.34. I'm still going to say it is 1.34 standard deviations, but I'm going to say that it is below the mean since z was negative. All right. Questions on that? Okay. Word of caution, because I see this a lot. I see students not write standard deviation. I see a lot of students do that. That is incorrect. If you just say it is 1.34 below the mean, that's like what? $1.34? Points? I don't know. Hours? Like, I don't know, okay? So you gotta tell me it's 1.34 standard deviations below the mean. And please don't write double negatives here. Don't say it's negative 1.34 standard below the mean. Looks like a double negative, so don't want that either. Okay? All right, why don't you guys practice it? Numbers 5 and 7. I'll see what you guys get. All right, go for it.
My bad.
All right, so answers to 5. Let me just go ahead and just tell me like the statement. Like x is this is about blah, blah, blah. All right, let's go Selena. What did you say for 5? Excellent. All right, so x is equal to 15.9 is about 8. Sorry, let me try and catch up here. Is about 865 standard deviations below the mean. All right, so double check a couple things for yourselves. Make sure you wrote standard deviations. Double check, make sure you wrote standard deviations. Make sure you didn't put negative here. Make sure there's no negative there, okay? So it should look just like that. Good, nice, Selena. Okay, Ethan, what did you get for 7? of giving my students their test grades, I gave them their Z-scores.
Oh.
So, out of these 4, which Z-score would you want? 4, 5, 6, or 7? This is the only one that's above. All right, so definitely 4. Which one is the worst to have? 7. Yeah, 7 would be the worst. So it's 2.13 standard deviations below the mean. That puts you right around here. Okay, that's you. All right, number 7. Oh, sorry, wrong side. That's you. Number 7, that's definitely in the F range. Okay. Number 4, 1.2, almost 5 would be like here. Alright, so that's not bad. That's like B range. Yeah, so that's like number 4. That's like B range. This would be A range. This would be C. This would be D. This would be F. Alright. So, yeah, it was kind of fun. I gave them their Z score. Then I figure out what grade they got there. Alright. Good job, you guys. Let's finish this off with the back. We're going to do some calculator stuff here. Similar to binom, all right? But this time we are in the normal distribution. All right. So for this one, it says the time it takes a bicycle courier to deliver a parcel to his furthest customer is normally distributed. When you see that, those words, you know, okay, bust out this curve. Okay? Mean of 38.6 minutes. Standard deviation of 4.7 minutes. Alright, that's the notation. You don't have to. But if you go into stats later on, you're going to know the notation. Mu for mean, sigma is for standard deviation. And your calculator uses this too. Alright, so part A, about what percent of the courier's trip to this customer take between 35 and 40? So in my mind, I'm thinking, okay, whoa, I'm thinking, all right, I know 38.6 is in the middle. 35 is maybe like down here-ish. 40 is a little bit closer, around here. And I want to figure out this area. That's what it's asking me essentially, is find the area under the curve between 35 and 40. Okay. So take out your calculator and go to the same place we found binom CDF. But this time, looking at that menu, what do you guys think we're going to use? Normal, yes. And actually not PDF, we're always going to use CDF. Number 2. We're always going to use CDF. Alright, so for this one, I want to go from 35 to 40. Alright, so this is part A, right? Yeah. So I'm going to do normal CDF. Alright, go ahead and click on it. Now it's asking me for a lower bound. Okay, now what that means is in the area that you're trying to find, what is that bottom number? So in that case, 35. Your upper bound is the area that you're looking for. Where's the upper cutoff? So that's 40. The mean, they tell you, is 38.6. And the standard deviation, they tell you, is 4.7. All right, so that is your work, and that is your answer. Make sure you show me this work. And then give me your answer. So. All right. Part B is really similar. Skip it. Part C. About what percent of the courier's trip to this customer take less than 30 minutes? All right. Less than 30 minutes. big number. Either 0 or negative big number. I know the negative doesn't make sense in the context of this problem, but it could make sense in other contexts. So you just want to give a really, really low number. Okay, so either 0, negative 999, it's up to you, up to 30 with the same mean and standard deviation. All right. Enter, and I get 0.0336. And notice if I were to plug in 0 instead, you actually get the same answer. It shouldn't be much different. Let's try it. Yeah, up until however many decimals that was, it actually ends up being the same answer. So either way, Okay. All right, questions on that? Yeah, Nathan.
Shouldn't it be like 3.36% because it's asking for the percentage?
It is, yeah. You could write in percent. Honestly, I like decimals better. It's just less right. But if you write in percent, perfect. Yeah, you're good. Either way. All right, why don't you guys try it? Number 9, give it a shot, and then I'll call on some people and see what answers you got. All right, go for it. All right. Okay, here we go. Let me just get your answer. Of course, you have work to go with it, but let me just get the answers to see if you got it correct, and then we'll go over the work if anyone needs it. Okay? All right, here we go for part A. What did you get for this one? Let me call on Audrey. All right, Audrey, what did you get for part A? Okay, perfect. All right, 8.73%. Or if you wrote it as decimal, totally fine. I'm okay either way. Okay, nicely done, Audrey. Next one, Chris, what'd you get for part B? Nicely done. All right, so either that or percent. Again, totally okay. All right, and then lastly, Ethan, what did you get for part C? 0.029?
Oh, sorry, 0.
There it is. All right. Or 2.91%. All right. Does anyone need to see the work for any of those? No, it's a little more straightforward. Awesome. Okay. Good job, you guys. That is it for today.